Mixture problems. At the end of this video, you should be able to solve a mixture problem. A problem for which the one compartment system provides a useful representation is the mixing of fluids in a tank. Let A of t represent the amount of a substance in a tank at time t. In order to use the compartmental analysis model, we must be able to determine the rates at which this substance enters and leaves the tank. In mixing problems, one is often given the rate at which the fluid containing the substance flows into the tank along with the concentration of the substance in that fluid. Hence, multiplying the inflow rate, which is volume over time, by the concentration, which is amount over volume, yields the input rate, which is amount over time. The output rate of the substance is usually more difficult to determine. One simplifying assumption that we might make is that the concentration is kept uniform in the mixture. Then, we can compute the concentration of the substance in the mixture by dividing the amount A of t by the volume of the mixture in the tank at time t. Multiplying this concentration by the outflow rate of the mixture then gives the desired output rate of the substance. Therefore, the rate of change in the amount of the substance in the tank with respect to time is equal to the difference between the input and output rate. R in is the input rate and R out is the output rate. Example: consider a large tank holding 1000 liters of water into which a brine solution begins to flow at a constant rate of 6 liters per minute. The solution inside the tank is kept well stirred and is flowing out of the tank at the same rate. If the concentration of salt in the brine entering the tank is 1 kg per liter, determine when the concentration of salt will reach 0.5 kg per liter. Solution: let A of t represent the amount of a substance in a tank at time t. The inflow rate is given as 6 liters per minute and the concentration is 1 kg per liter. Find input rate R in by multiplying these two values. Therefore, R in is equals to 6. Since inflow rate is equals to outflow rate, the volume of the mixture will maintain. Compute the concentration of the substance in the mixture by dividing the amount A of t by the volume of the mixture. Find the output rate of the mixture by multiplying this concentration by the outflow rate. Therefore, output rate R out equals to 3A over 500. Using the formula dA dt equals to R in minus R out, substitute the value of R in as 6 and R out as 3A over 500. Rearrange, and this will give us a linear differential equation. Solve the linear differential equation using the method that we have learned in chapter 2. Then we get the equation A of t equals to 1000 plus CE to the power of negative 3 over 500 t. Since the initial amount of the salt in the tank is unknown, we let A of 0 equals to 0. Therefore, we can find the value of C. C is negative 1000. Next, we want to determine the time for the concentration of salt to reach 0.5 kg per liter. Use the concentration formula A of T over volume and make it equals to 0.5. Solve for T. Thus, the time for the concentration of salt to reach 0.5 kg per liter is 115.5 minutes. Watch another example from the next video. And don't forget to try these quick check exercises. State your answer in the comment section.